Hello and welcome to the TechBrain channel. In this video, we'll be covering the top 5 beginner mistakes when using MongoDB. The first mistake is improper data handling. As we know, MongoDB is a NoSQL database and its schema design differs from relational databases. Beginners will often try to replicate relational database design in MongoDB, leading to inefficiency. So let's look at this first point. I have a new project. I've moved to MongoDB. I've heard all the good stuff about the MongoDB platform, and I'm trying to implement some sort of schema. I might have extensive knowledge of using relational databases, and naturally, what I might think is a reasonable thing to do is to port that knowledge without adaptation to MongoDB. So we'll start with a schema design. In this schema design, we'll say something like we have maybe an employee or a person, and a person has many hobbies, for instance. So let's model that. So we'll say that our document looks something like this. So there is a name, and this person happens to be John Doe, and these are the hobbies that they've got. So instead of just embedding information about the hobbies, what I do is add some sort of identifiers in that list, essentially foreign keys. And then I save that. So the rationale behind this might be that I have many other documents and I would like to be able to share this information without duplication. So I'm thinking along the lines of third normal form when I do this. So let's insert this document. Let's add another field in here. So it might be an address field. Address. And my address will say city is that, and country is Zambia. Okay, so we've got our document. Just make sure that it closes up nicely. Does that look fine? It does. So I'll insert this into a collection. So we'll say DB. In fact, I'll say use some other database. Use demo, and we'll say db.people, and we say insert one. So I'll insert that document. And if I do a query on that document, on that collection rather, this is what I'll see. So I'm keeping the hobbies in some sort of a hobbies table. So I'll say, what are the hobbies? And I'll go and say, I have the following hobbies. So let's define an array of hobbies. So our first hobby, we'll give it an ID. In fact, better yet, we'll do something like that. Underscore ID1. What hobby is this? So this is the name of the hobby, and we say it's maybe golf. And the next hobby, and that's a document. So likewise, I'll have another one of these, and that will be my ID2. So I'm using underscore ID because I'll be inserting that. Underscore ID will be the primary key. So just makes it a little bit easier. And this is going to be something like cars. And then the next hobby, that might be something like ID6. And what's the value? Name is equal to gardens. Okay, so that looks about right. I'll then say db dot hobbies and insert many. So insert those documents into that collection. So if I say db dot hobbies and we'll say find, this is what we see. So now to find John's hobbies, I need to do some sort of a lookup. How do I do the lookup? So first of all, these are the hobbies that I've got. So I can do something like db dot hobbies, rather John. So we'll save that in a variable. We'll say that we have person, and person is equal to whatever we find here. So say people find where name is equal to John Doe. So I'm trying to do a lookup to get the hobbies for John Doe. So that's my query part. I can also include a projection, and in this projection we'll say that we want to see just the hobbies for this person. Hobbies, and obviously underscore ID will come back. And this will be find one. So we'll say find one. And am I missing anything? That looks about right. Okay, that looks about right. So if I now look in person, that's what person looks like. So to retrieve the hobbies for this person who happens to be John Doe, I need to go to db.hobbies and do a find. We get the result, but this is not an efficient way of working. Certainly not the recommended way of using MongoDB. Do not use MongoDB with this idea of foreign keys. There will be cases where you can do this, but in the majority of instances, what you want to do is to be applying some sort of embedding strategy where you apply that information, you embed that information directly. So just to recap, this is the model that we've got. We've got the following two collections, db.people, and we do a find there. And then we have another collection, which is hobbies, and we do a find there. So the rationale for this design is that somebody would be doing a lookup, but clearly this is inadvisable. How would we fix this? So the resolution to this is to actually embed this information directly. So for the normalization purists out there, that might sound like absolutely not the way to do it. That is the way it's done in MongoDB. So I can remodel that as follows. So I'll say insert one, and then this other document with the name Mary Doe then has hobbies modeled as follows. So we've got cars, she's interested in cars, and also interested in golf. So those are Mary's hobbies. Okay, so we insert that. So the information that pertains to Mary is in Mary's document. So db.people, and we do a find. So this is what it looks like. That's the schema that we had which is not the way to do it in MongoDB. And this is the other schema. Perhaps just to clarify, there will be cases where you have to do this. There will be cases whereby you have to link to other data. And normally you do that when you've got a rapidly changing dimension. So for instance, if the documents that I'm linking to or the data that I'm linking to is referenced widely within my domain and it changes constantly, then it makes sense to just have a reference to that data. Typically, what you do is model your data in this way. Okay, so that was the first beginner mistake, using MongoDB like a relational database. The next beginner mistake, which follows on from what we've just been doing, is querying without an index. Let's look at these queries that we've been running. When we do a find, let's say if I do a find here, I'll change this to a find, get rid of everything else, we get our result back. Question is this query running efficiently? So I can use explain with execution stats to determine just how efficient this query is. So execution stats or explain execution stats will run my query and return the results. Run my query, return the results, and also compute the relevant statistics. So let's get to run it. So I can see clearly here that the command that I sent was a find, and that was the filter, and it was on that database. Now, how was the query actually executed? So the query execution itself involved an execution stage referred to as a collection scan. This execution stage tells us that the entire collection or all documents in the table were scanned. If I have many documents in this collection, that's quite a lot of compute going on. If I don't have sufficient resources on my server, it also means that things will have to be paged into the cache for this query to be satisfied. So this is inefficient, as we can see from the call scan there. So we can see that the winning plan is essentially a collection scan. We're having to scan the entire collection for us to be able to get the results. What is that similar to? Scanning an entire collection is a little bit like going through a book and scanning every page to find a topic of interest or a word of interest. It is going to be much more efficient if I go to the back of the book, look at the index, looking for this word that I'm interested in within the book. Might be a book on archaeology and I'm interested in, say, Neanderthals. Instead of flicking through every page in that book, which might be several pages long, instead of flicking through every page, what I could do is simply go to the index, find the term Neanderthal. It's on page 97, and then straight away I head over to page 97. So a call scan is very similar to having to flick through every page in the book looking for trying to find the information I'm interested in. So we need an index for every query that we have in MongoDB without exception. So the index we require in this case is an index that includes the field that we're referencing in the query or in our query. So let's look at the fields that we have in our query. So the fields I have in my query, we have a name field and a hobbies field. So there are two fields here. So the index that I define must contain these two fields. An index that contains more than one field is called a compound index. I'll create it simply by going here and say, yeah, people, and then create an index. And this index will have the first field, name, second field, So this tells us that name should be ascending in the index, and hobbies should also be ascending. So I have created an index. Now there are special rules or guidelines that we need to adhere to when we create these compound indexes. I won't cover them in this video, we'll be covering them in the next video. So in the case of this compound index, we have two fields. So the index has been created. If I rerun my query, I should expect to see a different output. So the output will have a reference to the index that I just created. So we now are scanning through the index. So we have an index scan stage. So we're actually scanning through the index. And as we scan through the index, we're looking for a particular set of terms. Name is equal to Mary and hobbies within that range. Okay, so that was the second beginner mistake, running queries without an index. So the next beginner mistake is storing large documents. You'll be aware that MongoDB has a document limit of 16 megabytes. So a document should not be more than 16 megabytes. However, what I might find myself doing is perhaps not even approaching the 16 megabyte limit, but creating a document that embeds information that is not frequently accessed. So beginners will often store excessively large documents by embedding too much data in a single document, and this can lead to performance issues. If you have large documents, try to break them down or try to reference just a subset of those documents. That will make your applications much more responsive and performant. The next beginner mistake is failing to monitor the performance and resource usage of your MongoDB database or installation. So there are tools that will let you do that. So depending on what version of MongoDB you're running or how you've deployed MongoDB, if you're running Enterprise, if you're running Atlas or Community Edition, there'll be a number of different tools that you can use to monitor. And of course, there are third-party integrations that allow you to create dashboards to monitor performance and resource usage. We do have within MongoDB a set of tools, MongoDB tools, and included in that is MongoStat and MongoTop. So let's get to use those. So I'll go here and we'll launch something like MongoStat. So be able to see from the output of MongoStat that it reports about queries, updates, inserts, and also the utilization of resources. So that's the output that we get, very similar to something like top. The other tool is MongoTop. And this tool will allow you to be able to see the hottest collections, the busiest collections. Also gives you metrics for read, write, and also the total for those two things. So if you have any database that's doing a lot of work, you'll be able to see how long the reads are taking, how long the writes are taking. So monitor your systems. So if you're using something like Atlas, you've got extensive monitoring tools within Atlas. You've got dashboards and a range of metrics that allow you to monitor your system performance. So that was beginner mistake number 4, failing to monitor performance and resource usage. The next beginner mistake is ignoring schema design flexibility. If you stick rigidly to predefined schemas, then you're really not leveraging MongoDB's flexible schema. Also, if you fail to adapt your schema as requirements change, you'll be missing out on the benefits of MongoDB's dynamic schema capabilities. MongoDB offers us the chance to evolve our database without downtime. You don't have to do any schema migrations if you want to add additional fields to your schema. So take advantage of that. Relational databases generally require some downtime. If you're going to add a new field, remove a field. With MongoDB, you can introduce these fields on the fly. Likewise, in MongoDB, if you need to enforce schema controls, you can also do that. You can have fixed schemas, but mostly the power of MongoDB is derived from using flexible schemas. So that was beginner mistake number 5, ignoring schema design flexibility. So remember, leverage MongoDB's schema flexibility, but ensure you still have some structure and validation using schema validation if you need to. So that brings us to the end of our video today, where we discussed 5 beginner mistakes in MongoDB. They were improper data modeling, not using indexes for queries that you might be running, storing large documents, failing to monitor performance and resource usage, and ignoring schema design flexibility.